Okay. See here, the first law of motion says that a body remains to be in the state of rest or in the state of motion unless and until it is compelled by an external periodic force. So, so what are the two concepts which are derived from first law?
Friction and inertia.
It's friction and inertia. Okay. So what is friction?
Opposition to the motion.
What is friction?
Opposition to the motion of the body.
Very good. Opposition to the motion of the body is said to be friction. So how many types of frictions we have altogether?
Four types.
What are they?
Static friction, static friction,
Limiting friction,
kinetic
kinetic
friction,
friction, and rolling friction.
maximum static friction, rolling friction.
Very good. Static friction, limiting friction, or maximum static friction. Third one is kinetic friction or sliding friction or dynamic friction. Fourth one is rolling friction. So these are the four types of friction. Okay. So generally the second one, limiting friction, is not described. Okay. They just say Fs max. That's it. Now coming to inertia. What is inertia?
The inability of the body to remain in the same state of rest, motion, or direction.
Very good. Inability of the body to remain in the same state of rest, motion, or direction is said to be inertia. How many types of inertia we have?
Three
types.
Three types of inertia. Okay. What are they?
Inertia of
at rest, inertia of motion, and inertia of direction.
So inertia of rest, inertia of motion, inertia of direction. Three types of inertia. And I have given example for each. So the example for static inertia at rest is what? Like you sit in the bus and the bus starts. When the bus starts, you go back. Means still you are in the state of rest. That's the reason you went back for a moment. Now come to the second one. What is inertia of motion? You stand in the bus. The bus is moving and the driver applies the brake. You fall in front. Even though the feet has come to rest, the body did not come to rest. Third one is inertia of direction. Inertia of direction says that when the driver takes the right turn, you are thrown on the left hand side. So means you're still in the same state of motion, direction. That's the reason you were thrown on the left hand side. Now, after that comes momentum. What is momentum?
Productive
mass and
Productive mass and velocity.
The product of mass and velocity is known as momentum. Okay. Product of mass and velocity is known as momentum. So P equal to what? P equal to
MV.
mv. P equal to mv. Product momentum equal to mass into velocity. What are the units of momentum? What are the units?
kg meter per second.
kg meter per second or Newton second. And also we have one more thing there. What is that? You can Newton kg meter per second or Newton second. And also please write the dimensional formula ml t to the power of -1. If there is space, just write ml t to the power of -1. That's the dimensional formula of momentum. Next comes Newton's second law of motion. What is Newton's second law of motion? What is Newton's second law of motion?
The rate of change of momentum is directly proportional to the applied force and accelerates in the direction of the resultant force.
Yeah, the rate of change of momentum is directly proportional to the applied force and accelerates in the direction of the resultant force. So from there we got F is equal to ma. Okay, force F is equal to ma. We derived that equation. After that, we have the next one. What is it? Impulse. What is impulse?
Effect of force for a short duration of time.
Very good. Effect of force for a short duration of time is said to be impulse, or we say change in momentum. That is also impulse. So there are two formulas. I is equal to F into T, or I is equal to kg. F into T, or I is equal to
MV minus
MU, change in momentum. And what are the units? Kg meter per second or Newton second, same as momentum. Okay, so it is also a vector quantity. Now, next is what? After that, we studied about conservation of momentum, this concept. In conservation of momentum, we say in an isolated system, momentum is conserved. Okay, or the sum of momentum before collision equal to sum of momentum after collision. Okay, so there are two bodies. M1, M2, whose initial velocity is U1, U1 and U2. This is at the time of collision. After collision, they depart. Okay, with velocity V1 and V2. So the simple formula is M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. So this is what we have done. And we have done some examples in the impact, in the impulse. There is fielder taking a catch. Why? Because when he's taking the catch, he pulls his hands backward to reduce the impact on his hand. The second one is crockery electronic items. When they are taken from one place to another place, when packing, they use paper fillings or thermocol or carton pieces so that when they touch each other, they should not break. Okay, so the impact is absorbed. The shock is absorbed by the paper fillings or thermocol or cartons. So, or in high jump also, the person is jump. When he jumps, there is a cushion. So the cushion goes down and comes up. So the more the time, less will be the impact on the person. So this is about this is about the conservation of momentum. So, sorry, example of impulse. Next one is in conservation of momentum. We will discuss few concepts. Well, that is recoil of a gun, collision, then explosion of a bomb, and rocket propulsion. These are the 4 examples. There are so many examples, but I am using only 4 for time being. Okay, for time being, I will use only 4. Okay, so now. So here, we start with the example. First example, that is a rocket, that is recoil of a gun. Recoil of a gun. And recoil of a gun. So what happens? Suppose so this is a gun, and there is a bullet in it. Okay. Now what happens? This is initial. And this is the final. In the final, what happens again? Okay, so the bullet comes out. So this is the recoil of the gun, and this is the velocity of the bullet. V and capital V. This is capital M, this is small m. And here capital M and small m are together. Okay, they are together. So this is of James Bond. The new movie of James Bond. Any idea? No idea. Okay, there it is. Now here, suppose we have this is a final. So here we have in the initial momentum. So we have the formula capital M plus capital M into U plus small m into U. That is initial velocity is 0. Both are at rest. Okay, initially both are at rest. Equal to what? Capital M into V plus small m into V. Okay. So final momentum. So what will happen? This is completely 0. Equal to what? MV plus small mv. So we are writing here MV is equal to minus MV. V is equal to what? Minus M into small v by capital M. So this is the recoil of a gun. Means why we are getting negative when we take the gun, when you hit it, what happens? It comes back for a moment. Okay, like this. When the bullets are moving forward, gun recoils in the backward direction. So this will happen. That is the reason there is a negative here. Okay, because the direction of the recoil in opposite direction. This way. Clear? So this is the first example. Second example, the already about the collision we have seen. Okay, in collision we have 10 cases. We are not going to discuss all the cases, just a simple case we have discussed. Okay, so in collision, what will happen? Suppose there are 2 bodies. So M1 and M2, whose initial velocity is U1, initial velocity is U2. This is at the time of collision. This is at the time of collision M1, M2. The momentum transfer takes place here at that time. And then what happens? So this is M1 and M2. This is V1 and this is V2. Okay. So what is the formula? M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. This is the formula for collision. Okay. Third example. Third example is what? What was the third example? Rocket propulsion and?
Explosion of a bomb.
Yeah, explosion of a bomb. So here, an explosion of a bomb. An explosion of a bomb, like suppose this was a bomb. Okay, suppose the bomb, initially the total mass is capital I. Now, when the bomb explodes, the fragments, they explode in different directions. Okay, the fragments move in opposite, so many directions, different directions like this. Okay. Let it be M1 like this, M1, M2, M3, M4, M5, M6, M6 and M7. There are so many particles. Like maybe the fragment got divided, the bomb exploded into 7 fragments. Example. Now, the velocity is what? V1, V2, V3, V4 like that. Okay, corresponding velocities. V1, V2, V3, and then V4, V5, V6, V7, V5, 4, 3, 3, 4, this became 5, 5, 6, 7. 6 and V7, this is V8. Okay, so what will happen now? The capital M into U. Okay, when we take initial velocity for 0, equal to what? M1 V1 plus M2 V2 plus keeps on going plus. So because see, if this direction is positive, this direction will be with the right hand, left hand, sorry, I mean, if the left hand side it is positive, right hand will be
Negative.
negative. So we have to take, if this is in the same direction, it will become 0. Okay, so you can take 3 as positive, 3 as negative. Okay, so you can take plus M3 V3 minus M4 V4, sorry, minus M5 V5. Like that, you can take M6 V6 minus M7 V7. Like that you can take. Okay, so 3 are negative and 3 are positive. That is how the explosion of the bomb takes place. Clear? Is it clear?
So
About it?
everything can be taken negative from the right side.
Suppose if you take this as positive, you take this as negative. Opposite direction.
Yes, ma'am.
If this direction is positive, the other direction will be negative. Okay, like that way you can take. Clear?
Yes, sir.
Okay. Please copy this, the last will. Why does the gun recoil? Any reason behind it?
Because of the velocity by which the bullet is shot.
Yeah, there is a spring in it. Okay. See, there is a spring in it. We said coil, recoil. You know, coiling in the old clocks or watches, we used to have a key on the back side. Alarm pieces or like clocks, we used to have a key on the back end. So every day we used to have the key. My grandfather, great grandfather, they used to have this type of clocks. Every day morning they used to get up and they used to have keyed. We say keying. Okay. Then till the next day it runs. Again, next day again they have to give the key again. Means what they are doing exactly? They are coiling. In those days we did not have this battery or cell operated clocks. So we have to give the key. Or they have to open the front part of the panel and they have to put the one key and rotate it. Means they are coiling. And slowly what happens, the energy which is stored in the spring, it slowly recoils. Okay, that is what we recoiling. Coiling, recoiling. The spring is in this way actually. The spring is like this. It's like this type of spring. You might have seen in the toys also. So what happens when we coil it? Coiling means all this will come very closer, very closer, very closer, very closer like this. When it is moving away, it starts releasing the energy and it gives out the energy, and that is how the clock works. Clear? Now we'll go ahead. So here we have rocket propulsion, the fourth one. So in rocket propulsion, you might have seen the rocket, okay? So these are the lobes, and this is the The gas is coming out from here. Okay, so the rocket goes up. Here. Now, so here, capital M is the, and V, small m is the mass of the gases escaping. Small v is the velocity of the gases escaping in time t. Okay, rocket in small time t, and capital M is the mass of the rocket, and v is the velocity of the rocket. Now, initial momentum is 0, both were at rest. Now the rocket is moving, gases are coming down, escaping from the bottom, and it will fly. Okay, here m is what? M is mass of the rocket. M is mass of the rocket. So, and small m is the mass of the gas escaping per second. Small m is mass of the gas escaping. Mass of the gas escaping per second with velocity v. With velocity v. And here change in momentum of gas in t seconds. MVT is MV into T is change in momentum of the gas in t seconds. Okay. So what happens now? Here we write here. So capital M into V plus small MVT equal to 0. Now capital MV is equal to minus MV and T. MVT, cross multiply this. V by T, capital V by T equal to minus MV by capital M. This is what? This is equal to acceleration. This is the acceleration. So how do we calculate the acceleration? A equal to minus m into v by capital M. This is the acceleration of the rocket. Once again, see here capital M is the mass of the rocket. Small m is the mass of the gas escaping per second with velocity. MVT is what? Change in momentum of gas in t seconds. How much change in momentum? Now we are adding both the momentums, m into v plus m